Hello, everyone. In this lesson, we will learn about the control of parking space using S7-1200 PLC, focusing on the principles and applications of counter instructions. Through this lesson, we will achieve the following learning objectives. 1. Memorize the 3 types of counter instructions. 2. Explain the principles and differences of each counter. 3. Use counter instructions to write control programs for parking space counting, pedestrian flow detection, automated product counting, and indicator light control, and perform online debugging. The knowledge framework for this task includes 3 types of counter instructions: count up counter (CTU), count down counter (CTD), and count up and down counter (CTUD). Let's get into the knowledge points below. A counter counts the number of incoming pulses. Each time a pulse arrives, the counter increments by 1. When the count reaches a preset value, an action is triggered. The S7-1200 PLC provides 3 types of counters: count up counter (CTU), count down counter (CTD), and count up/down counter (CTUD). Their instruction block diagrams are shown in Figure 7.1.1. The table explains the meaning of each parameter in the counter instruction block diagram. CU is the count up input, CD is the countdown input, R is the reset input, and LD is the load input. The preset value is represented by PV, which is the value to be loaded. Q and QU are the outputs for the count up operation. When the current value, CV, is greater than or equal to the preset value, PV, the outputs Q or QU will be 1. Q and QD are the outputs for the countdown operation. When CV is less than or equal to 0, the outputs Q or QD will be 1. CV represents the current value of the counter. DB is the data block for the counter, primarily used to store various parameters of the counter. First, let's learn about the count up instruction. The count up, CTU, counts the number of rising edge pulses at the CU input, outputting a signal when the count reaches the preset value, PV. As shown in Figure 7.1.2, Part A, illustrates the ladder diagram for the count up instruction. When I0.0 is activated, the CU input detects a rising edge, incrementing the counter and storing the value in MW30. When the current value, CV, reaches or exceeds the preset value of 4, the Q output becomes 1, activating Q0.0. If I0.1 is activated and a reset input is present, the counter resets, with the Q output reverting to 0 and the current value reset to 0. Part B shows the timing diagram, allowing us to better understand the states of the counter parameters by comparing it with the ladder diagram. The count up instruction has a wide range of applications. Let's consider an example. When the start button is pressed, the light blinks off for 2 seconds and on for 3 seconds, stopping automatically after 30 blinks. If the stop button is pressed during blinking, the light stops. Please design a program to meet the control requirements. We can implement this using timer instructions for the lights on, off blinking and the count up instruction to track the number of blinks. The designed ladder diagram is shown in Figure 7.1.3. Let's look at the design concept. Program segment 1 uses latching to maintain the start button signal. When I0.0 is pressed, the start indicator M2.0 is activated and latched. Program segment 2 employs 2 delay timers to control the lights blinking. When M2.0 is active, the 2-second timer delays for 2 seconds before turning on the light, Q0.0, for 3 seconds. This means the light is off for 2 seconds and then on for 3 seconds, continuously blinking with a 5-second cycle. Program segment 3 uses the count up instruction to record the number of blinks. When the CU input detects the falling edge of M2.2, the moment the light turns off, it counts as 1 blink. The counter increments by 1. When the blink count reaches the set value of 30, M2.4 is activated, disconnecting the normally closed contact of the start indicator to stop the blinking, and simultaneously connecting the normally open contact to the reset input, resetting the counter and the current value to 0. Now, let's learn about the countdown instruction. The countdown counter, CTD, outputs a signal when the count of rising edge pulses at the CD input decreases from the preset value, PV, to 0. Figure 714 shows the application of the countdown counter along with the timing diagram. In Part A, when using a countdown counter, I0.1 is pressed, the load input, LD, is activated, loading the preset value, PV, into the current value, CV, changing CV to 3, and the Q output becomes 0. When I0.0 is pressed, the CD input registers a pulse, decrementing the counter. After 3 pulses, the current value becomes 0, and the Q output, Q0.0, activates to 1. Part B illustrates the timing diagram of the states. Next, let's learn about the count up and down instruction. The count up and down counter, CTUD, increases the current value to the preset value, PV, when rising edge pulses are detected at the CU input, triggering the QU output. Conversely, it decreases the current value to 0 when pulses are detected at the CD input, triggering the QD output. Figure 715 displays the application of the count up and down instruction and its timing diagram. In Part A, when I0.0 is activated, the counter increments by 1. When I0.1 is activated, the counter decrements by 1. If the current value, CV, is greater than or equal to the preset value, PV, the QU output activates, Q0.2 is energized. When I0.2 is activated, the counter resets, the current value becomes 0, the QD output activates, and the QU output deactivates. When I0.3 is activated, loading input is triggered, setting the current value equal to the preset value, and the QD output is 0, while QU output is 1. Part B depicts the timing diagram of the states. In this lesson, we detailed the formats and principles of the 3 types of counter instructions in the S7-1200 PLC, explained the meaning of each parameter, and illustrated the usage of each counter instruction with examples, focusing on the application of the count-up instruction through programming. That concludes this lesson. See you next time.